Alright, let's get started on today's problems. First problem of the day is string to integer, atoi. Implement the myatoi function, which converts a string to a 32-bit signed integer similar to C or C++'s atoi function. Read in and ignore any leading whitespace. Check if the next character, if not already at the end of the string, is negative or positive. Read this character in if it is either. This determines the final result, if the final result is negative or positive. Assume the result is positive if neither is present. Read in the next characters until the next non-digit character or the end of the input is reached. The rest of the string is ignored. Convert these digits into an integer. Okay. If no digits were read, then the integer is 0. Change the sign as necessary. Okay. I see. First of all, I think using the trim function would be pretty nice. This trim start should remove any white space. I think there's a general just trim function. Let me see. Okay. Oh yeah, having the leading and trailing white space removed. Okay, so s.trim. And that returns a string, so we'll say var trimmed string. I think the solution here is just to perform a sort of linear scan on the string and do the proper modifications. The main issue will be dealing with the zeros. In particular, determining between leading zeros and zeros that have context. And what I mean by have context is that they indicate that there is actually a sort of, how should I say it? That there is a additional power of 10, I guess, that's being incremented by. So for example, we want to deal with 0032 as 32, but if we do 1032, then we should read that as, well, 1032, right? So I think the strategy for this will probably be read zeros at the beginning until you hit either a decimal or a zero or a non-zero number. Let's see. So we've trimmed the white space in the beginning. And we're going to need a var sum, which is going to represent our integer in the beginning. We're going to say var what can we do? Well, what's the size of the string possibly? It could be 0, right? So if s.size is 0, return 0. Length. And let's see. So is it possible for it to just be a minus sign here? And if so, what should that return? That should return 0, okay. Okay. So we can say val sign is equal to s get at 1, because we know that there will be a value, there will be at least a size 1, right? So index 0. We'll wrap this in a when. If it is a minus sign, then it's -1. If it's a positive, then it's a 1. Otherwise, actually, we could just do else 1. Right? Actually, I want to do this a little bit differently. If sign is equal to, or if the s or trimmed string at 0 is negative, sign equals to -1. Else if trimmed string 0 is positive, sign is equal to one. Else, sorry, I was just thinking about the other inputs that we could possibly have. Return 0, or return, ooh, because the idea is that if it matches, if it's a digit, then we want to return the digit. If it's a decimal or anything else, we'll leave it at the basic, the most we'll leave it at the most basic sort of type now. So we'll just say that if the sign, if it's a negative, then it's -1, else 1. Then we can go through the string itself. And we'll say, let's see. When we do trimmed string for each indexed, we're going to need the index in this case. If the index is greater than 1 or greater than 0, right? Because we don't want to, we want to avoid reading the leading character. Well, but the leading character could be, or index is 0 and char is I think we could do a matches, right? With the regex. So we'll do a regex. We'll do a val numerical regex is equal to regex, and this will be 0 through 9. Go regex matches char. So if the index is greater than 0, or if the index is 0, and except if it is, actually, we can just do this. Keep it simple. So if it is a number, then we will do sum plus equals 2. I guess the problem is now that first we want to deal with the leading zeros, right? And then we also want to make sure that we want to deal with the leading zeros, and sorry, we want to make sure that we're adding the numbers properly. So I think in that case, I'm going to do a var has scanned leading zeros is false. And we can say if char is 0 and not leading zeros gone. Actually, we can do if not 0 or, so if the value is a 0, or if the value is not a 0 or the leading zeros is gone, if we haven't set that flag, then we will now. Then we will do sum plus equals, or times equals 10 first, and then sum plus equals char. So this should be, what it'll do is that it'll multiply whatever we had by 10, because we are at the next character. And then we'll add our character in. At the beginning, at the first 0, or at the first like the actual leading digit, then it'll just multiply 0 by 10, which doesn't really affect our output, so we're fine there. Let's see, what else? So that should take care of our most basic case, right? And then we can say else if numerical regex, or no, if char is equal to dot, then we can say var has found decimal. And we want to make sure that basically, if we found a decimal, what we want to do instead is sort of do the inverse. So we want to divide our value, or we want to keep a value. Actually, will we have decimals? Well, we will have decimals, but they want us to return an int. S consists of lowercase, uppercase English letters, digits 0 through 9, whitespace, plus, minus, and period. But our output must be an integer. So I guess we just don't care about that. Numeric or general regex is plus minus. Actually, we don't care about the that anymore. If we encounter something afterwards, then if index is greater than 0. Actually, no. Hmm. Oh, also we need to multiply this by the sign. Okay, so I think we need to actually keep that there. Index is 0. Hmm. Else if index is 0 and char, if the index is 0, if char is negative, sign is equal to -1. So we can do var sign is equal to 1. So that gets rid of the sign situation. Else break. Can we break out of a for each loop? We'll see. We don't need this has found decimal because the decimal really doesn't matter. Even though the decimal is included in here, I don't think it actually does matter within the context of this design spec. I don't see any reason that we care about that decimal. Let's see. We probably do want to do a clamp. That would probably be a Java thing. Java docs clamp integer. Oh, okay. We can say if sum or if sign is equal to 1, then sum plus equals char, else sum minus equals char, in order to actually accommodate for the negative numbers. This will read in the zeros no matter what, it just won't process them if that's the case. Let's see what else. I think that's fine for now. I'm just thinking about how to process the numbers. Let's say that we're not allowed to use the parse int at all. Or rather, yeah, the parse int. But what if we did, though? I have a feeling that this won't work. Assuming that the Java specs is correct in saying that it's only integers. If it's only integers, ASCII table. What's the number for 0? Decimal. Or actually, I could just do character 0, right? Character 0 to get the offset, and that should work. Let's see what else. The sum should work as intended. Non-digits. We just really need to worry about a here. We can say if sum is equal to integer dot max value divided by 10, or greater than or equal to let's see. How do I clamp the integer in a way that makes sense? Is there no like a... Maybe there is a clamping method in here and I'm just not it's definitely not in the integer spec. Actually, we could have probably two paths for this. So if sign is equal to 1, then we do this. Otherwise, we do this. And we can just do this. Actually, sum is greater than or equal to integer dot max value divided by 10, or sum is less than or equal to integer dot min value divided by 10. Otherwise, we do this. If the sign is equal to -1, if we're equal to max val divided by 10, then when we multiply, then we would do just thinking. I feel like this is the surprisingly difficult part. I imagine that something like Python might have like a library to do this. Which is why I should use Python. Or maybe there's a Kotlin way to do this. Is there really no clamp? No, I guess not. Let's see. plus char minus 0 is less than sum times 10, or less than what we have right now, then we probably overflowed, and we just set it to that. Otherwise, sum times 10 minus char minus 0 is greater than sum. Sum is integer min value, and this is if sign is 1. If the sign is -1, otherwise we just do that instead. We just perform as normal, and we do sum times equals 10. If sign is 1, sum plus equals char minus 0, else sum minus equals char minus 0. So this is basically just really, I guess, rudimentary overflow detection. And we want to make sure that these are being connected in the proper way. And yeah, I think that's it. Let's see. Length is 0, return 0. We trimmed the string of the white space in the beginning. We just produced a regex. We have a sum that will go up, and then a sign value. We don't know if we've gotten rid of the leading zeros. That's something that we'll check. First off, if we match at index 0, what happens if we do just do a period? Char, but char sequence was expected. Okay. Char sequence, huh? Can we just create a char sequence from char? Where's the init? It's an interface. Fine, we'll do trim string dot substring from index to index +1. It kind of defeats the purpose of this char really in the first place, but well, I guess we use it elsewhere, so it's not a total loss. Break and continue are only allowed inside a loop. Isn't this inside a loop? Yeah, we can just return immediately at that point then. Okay, let's just run through the example test cases and let's see how we fare against those. sign is like that. So we do. Oh, I see. Because we do the minus equal thing. In that case, we probably don't care about multiplying by the sign then. If we get rid of it the other way, we could also get rid of it the other way, yeah? Yeah, we could do that. So we can have this be a more sort of clean thing. So we start by adding up pretty much the magnitude. But then that presents its own problems with the underflow. Yeah. Okay. That's funnily enough, talk about underflow. How did we underflow? Gonna print sum and our sign, and let's see whether we went wrong here or whether we went wrong somewhere else. I don't care about you for now, don't care about you for now, just you. Interesting. But yeah, this presents interesting underflow questions also. Our sum underflowed, interesting. Let's see where it's going wrong. It has to be going wrong somewhere in between. Sum is 4. Then we break it? Why don't we do the if sign is negative, let's see. Let's see. Let me think. So if the sign is -1. We're just adding magnitude. We start by adding magnitude. We don't care about the sign essentially until the end. So we need to limit it to if we did sum times 10 is greater than the sum. No, it doesn't matter. If we did do an overflow, then we just set it to a min value. Glad to know that that's the min value. But let me think about this some more because, man, this overflow thing is actually like surprisingly annoying. Because I imagine that it won't necessarily work for, and 2 to the 31. Let's try something like that. So that's 2 to the 31. Okay. And if I do something like, do some stupid stuff after that. Yeah, that just clamps it there. And if I did something like that and throw in a negative, this will probably break it. Yeah, because we set it to the min value there. But we're only adding the magnitude. If it's either this or the sum is already less than 0. Because if the sum is less than 0 before we flip the sign at the end, then we know that it underflowed, and therefore we don't want to worry about it. Okay, cool. I think that we actually handled the overflow and underflow cases then. I guess we can do like some weird thing like that to test out the zeros. Just to make sure that parses correctly. And this is a test. And then we can also do all leading zeros. Yep. Cool. Let's toss in a submit and let's see if there is any edge cases that we missed. In terms of speed, this is O of n, just running a linear scan pretty much. Output is 0.1 in that case. What is the period like supposed to be? Like if I did like 0.01, like what is that supposed to actually read as? Okay, so that reads as 0. But for some reason, something like 0.1 and 0.2 are supposed to be read as... What if I add like 0.23? Okay, so 2.23, that returns 23. So do we just ignore? Okay, so we just ignore it unless it's... Do we just ignore the period at the beginning? Else if... Actually, this should get rid of it, or this should handle it, right? Index is equal to 0. This should... Why doesn't it get caught up in this case? So it doesn't match this, but the index is 0, so it doesn't matter what it is, really. I'm not crazy, right? This is supposed to get caught up here. Oh, I see. Interesting. So yeah, it does skip the point. The 3... Oh, it's supposed to be 0. Whoops. And char is equal to plus, or char is equal to minus. Oh, sorry. Oops. This should be an and. Okay, so I was just looking at the prompt wrong. It's supposed to be, if it's a non-zero character, or if it's a point, then we just get rid of it entirely. Okay, I think that should work then. Let's continue, and let's see whether or not we can get through this. Let's see. Less than sum. Interesting. Looks like my underflow thing still has. Looks like it still has some issues that we need to work out. Honestly, you know what would be the easiest way to do this? Have this be a long. If we have this be a long, then we can just get rid of this. I'm tempted. I'm not gonna take the easy way out first, but just know that that is probably the easiest way out. So this goes to there. Is that larger than 2 to the 31? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 characters. Oh, probably when we multiply it and add. Let me think. So we have that there. If we did x10 plus char. What do we see? This sum times 10 gets to there. But that's not larger than 3, 4, 5, 6, 7, 8, 9, 10. Yeah, and this is 10 characters too. 7, 8, 9, 10. Why are we expecting an underflow situation? It's not an underflow. 3, 4. Oh, wait, why don't we add the last character to it? We didn't process the last character. Did we? Oh, looks like we did. Why isn't this being read correctly? Yeah, okay, so that's definitely larger than That's definitely larger than the max. Um, what if we just did this instead and not bother with any of that stuff? That really doesn't matter. I'm just confused about how this isn't overflowing. Um, Hold on 1 second. I'm gonna think about this a little bit off camera, just really quickly, because I need a bit of silence. Yeah, so this took a bit, but eventually I got it. Definitely not a fast solution though. The idea is that for both of these, we either check if it's greater than the integer max divided by 10. So that would be just, in that case, multiplying by 10 would automatically make it overflow, so we don't need to check anything beyond that. Or if it's exactly equal to the integer max value divided by 10, then we need to check the last digit that we're adding. If it's greater than 7 for positive numbers, or if it's greater than 8, greater than or equal to for both cases. For negative numbers, then we need to just return the min or max value. Otherwise, we can just sort of pin it and it won't exactly overflow. So that's sort of my solution, though you could probably run a long in this case, and you might be able to speed this up even further. So let's try using the long method, and let's see how fast we can get it. Dot to int dot to int, and this to int should clamp it if the language is nice. I think that's all we need to do. Let's just see if that actually works, or it'll throw us a compiler error. To int. Let's go with a long. Don't want a long array of to int. That seems fine. Why did everything break here when that happened? As long. Still not quite there. What if I just do, let's see, this? Interesting. It's really not happy about the usage of the sum as a long. Like everything is breaking. Interesting. This is really weird. I don't think I've ever really encountered anything like this before. Let's just do that first. And then are we allowed to do this dot to int? That seems to have worked. Okay, let's just slowly comment out code and see where things go wrong. That seems to have worked. Does this work? That works. Does this work? Oh, whoops. That's where it breaks. Let's just run some dummy code here and see if that actually works. That is really weird. That works. That works. Is it just a statement inside that it doesn't like? Maybe it was that. Okay. Honestly, did I accidentally add like a a close break like a curly brackets there that I just didn't notice? Interesting. It overflowed both of them? Interesting. I guess I could do like a... So it's this one that's causing me issues. Print line sign. Let's just do another one there because I'm not sure exactly. Actually, it should terminate the end. Yeah, that's fine. Looks like it should be fine. Interesting. Oh, the resulting int value represents the same numerical value. I see. So it doesn't really do the conversion part, I guess. Is there a way to like limit it so that it does? times. Oh, we could do a dot coerce in. Integer dot min value, integer max value. We do the same thing here. I might need to, yeah. This is definitely not a very elegant solution either, just converting the integer min values and max values to longs, but hey, if it works, then it works. It's a lot easier to read, at least, compared to the what's it called? It's a lot easier to read compared to the integer stuff, that I was writing before, in my opinion. I guess you could say, like, here it's like if sign is equal to 1, sign is, or if sum is greater than integer dot max value, return integer max value. If sum if sign is equal to -1, if sum is greater than integer min value times -1, return integer dot min value. And we can do this and this, and sort of shift these values upwards. We could probably inline that too if we really wanted to. It'll be funny when I realize that this probably isn't faster than the original solution that I put. That would be hilarious. But I think using a long is the right call here, because it's just, like, there's no reason not to. Oh. This should be max value. If the sign is -1 and it's greater than max value -1, actually, if it's greater than max value, max value is defined as that, min value is defined as that, +1. This needs to be a long. Dot too long. Because this needs to be a long, otherwise it'll break. It'll underflow. That works. Let's make sure that the example test cases work. Still lots of weird edge cases when dealing with longs. but it probably would have been a bit faster for me to get through this problem if I were working with them in the first place. Yeah, decently fast. Alright, cool. I guess we'll leave it here then. Hope you learned something, and I'll see you for the next problem.